In the previous video we discussed fractions in relation to square numbers and square roots. Thus you should be familiar with the following, that if we have a fraction, say the fraction 5 divided by 7, then it is evident that 25 divided by 49 is the square number. So you should understand that 25 divided by 49 is the square number of 5 divided by 7, because if we take the square root of 25 divided by 49, we simply have that the square root of 25 divided by the square root of 49, which is equal to 5 divided by 7, because 5 multiplied by 5 is 25, and 7 multiplied by 7 is 49. Now, if the number proposed to be a mixed number, say we have a mixed number and call it 12 plus 1 divided by 4, that is a mixed number which is equal to 12.25. We simply reduce it to a simple fraction by translating the integer 12 into a number which has a common denominator with 1 divided by 4. So we simply multiply 4 divided by 4, which is just equal to 1, by 12, and plus 1 divided by 4, which is equal to 48 divided by 4, plus 1 divided by 4, which is equal to 49 divided by 4. Okay, so you should be familiar with rewriting terms like that. And then we're going to discuss what actually is a irrational number. Because sometimes when you take the square root of a number, you might not be able to rewrite it in terms of fractions. And that is what we call an irrational number. For example, if we take the number 12, let me try to explain to you in terms of mathematical calculations why it is not possible to actually find a number, a given square number, which is not a square, as 12. So what I'm trying to say is that no matter what you're trying to do, you can never find or express 12 as a fraction. Well, let me show you why, and let me show you what is going on when we're trying to do that. So my claim is that the square root of 12 is irrational. Well, I'm not going to prove that. I'm just going to give you some details in terms of calculations to show you that actually when we're trying to get closer and closer to a number, which when we take the square of that number, we're getting close to 12, but it's never possible to actually take a number and take the square of that number and then exactly get the number 12. So we say that the square root of 12 is irrational. Because, well, let me try to show why it cannot be the case. I will not prove it to you, but I will do it, show it with calculations and show you it cannot be true. So let me start by saying that the square root of 12 must be greater than 3. And why do you think that is true? Well, simply because if we say 3 multiplied by 3, that is equal to 9. Yes. And likewise, the square root of 12 is less than 4, because 4 multiplied by 4 is 16. And we also know that the square root of 12 is less than 3 plus 1.5. Because, well, 3 plus 1.5 is equal to 7 divided by 2. And if we take the square root of, if we take the square number of this term here, we simply end up with 49 divided by 2, which is equal to 12 plus 1 divided by 4. So yet again, we came closer in this case here to 12. But, well, it is still different than 12 if we take the square root of this number. If we take, the square of this number. Because we have the 1 divided by 4. So it's different to 12 by 1 divided by 4. So let me try to get even closer. So yeah, I mean, we may approach still nearer to this root by comparing it with, say, take the mixed number 3 plus 7 divided by 15. Well, we can still try to see why this is not exactly the square root of 12. Because, well, if we take the square of 3 plus 7 divided by 15, we simply end up with, well, that is equal to 52 divided by 12 to the power of 2, which is equal to 2,704 divided by 225. And by doing some rewriting, that is equal to 12 plus 4 divided by 225. Well, so actually this number is closer to 12 than what we've seen before. Before we got to 12 plus 1 divided by 4. But in this case, we get to 12 plus 4 divided by 225. So we're getting closer to 12. But this is still not equal to the square root of 12. Because of 4 divided by 225. So it's different by 12, by 4 divided by 225. So, well, that's still a problem. So let's try with another example here. Okay, we may suppose that as, well, say, we may suppose that as 3 plus 1.5 and 3 plus 7 divided by 15 is greater than the square root of 12. It might be to add 3, a fraction, a little less than 7 divided by 15, and precisely such that the square of the sum would be equal to 12. So we're trying again with another example. So let us therefore try with the following. That's, well, 3 plus 3 divided by 7, since 3 plus 3 divided by 7 is less than 7 divided by 15. Okay, so let's try with 3 plus 3 divided by 7. Well, 3 plus 3 divided by 7, if we take the square of that number, we simply end up with, well, we have to take the square of this fraction here by rewriting. That is equal to 576 divided by 49. And consequently, this is less by 12 divided by 49 than 12. Okay, which may be expressed by 588 divided by 49, which shows that 3 plus 3 divided by 7 is less than the square root of 12, which is less than 3 plus 7 divided by 15. Okay, so we are still getting closer. I mean, now we have a lower bound here and we have an upper bound here. So the square root of 12 is in between 3 plus 3 divided by 7 and 3 plus 7 divided by 15. So yet again, let's try with another number. Let's try with so we want to find the number in between the two bounds right here, okay? So, well, let's pick a number which is greater than 3 plus 7 divided by 3. But also the number has to be smaller than 3 plus 7 divided by 15. Well, simply because we want to be in between this lower bound here and the upper bound here. Yeah. So let's try with a number. Say, try with 3 plus 5 divided by 11, which is simply equal to 38 divided by 11. And its square is, well, if we take the square of this expression here, we simply end up with 1444 divided by 121. And by reducing 12 to this denominator, we obtain, so we reduce 12 to this denominator. We simply obtain 1,452 divided by 121, which shows that 3 plus 5 divided by 11 is actually less than the square root of 12, namely by 8 divided by, so it's different. So it implies that 3 plus 5 divided by 11 is actually is different. It's not equal to the square root of 12 because it's different by, because it is different by 8 divided by 121. And as you may see, well, in that case, let us therefore substitute 5 divided by 12. Let us substitute the fraction 5 divided by 11 by the fraction 6 divided by 13, which is a little greater, and see what will be the result of the comparison of the mixed number 3 plus 6 divided by 13 to the power of 2. With the proposed number 12. Here, well, 3 plus 6 divided by 13 to the power of 2 is equal to 2025 divided by 169. And 12 reduced to the same denominator, 12 reduced to the same denominator. In that case, we have 2028 divided by 169. So, well, yet again, it implies that 3 plus 6 divided by 13, try it with your calculator, is still too small to be the square root of 12, but only by 3 divided by 169. So we're getting closer and closer and closer. And at the same time, we have that 3 plus 7 divided by 15 is too great. Okay, so I don't want to keep going any longer, but as I can show you here, we keep getting closer and closer and closer to the square root of 12. But actually, no matter what I do, we will never be able to express the square root of 12. So it is evident, therefore, that whatever fraction, or say decimal number, is joined to 3, the square of that of the sum must always contain a fraction and can never be exactly equal to the integer 12. So, well, let me just type it here. Although we know that 3 plus 6 divided by 13 is less than the square root of 12, which is less than 3 plus 7 divided by 15. Even though we know that we are unable to assign an intermediate fraction between these two, which at the same, if added to 3, would express exactly the square root of 12.